Okay, so this is the helper video for chapter 7 on economic growth. So a couple things I wanted to go over on this chapter, and one of them is this idea of the production function. So here, this figure is taken obviously out of your textbook because this is your textbook here. So you can see these are the various inputs that go into creating GDP, and then when we normalize this by the population, so we get GDP per capita, then you can see that we have these terms that go, these factors that go into the production function. They're also on a per person term there. Okay, and so just remember that when usually what we're really after lots of times let's see, many times is GDP per capita. That's the important term here. GDP is good, but it might be skewed a little bit because larger countries, larger economies are naturally going to have a higher level of GDP than others. But people in those countries might not lead the same level of standard of living as those in the smaller country, because on a per capita basis, that really takes care of that. Okay. The other thing I wanted to go over was, again, this issue of the growth formula. So again, growth formula. And that was GDP at starting date times 1 plus the growth rate of GDP to the number of years is equal to GDP I guess we can think of this as like, it might be easier to write this like this. Just make this to the n power, like a lowercase n, and just say GDP n years from now, or n years from starting date. In all honesty, that might be the way to go. All right. So for instance, let's say economy starts off at 100. That's GDP at the start. So that's equal to starting GDP. And the growth rate, let's say, is 5% per year. All right. Well, what is GDP 10 years from now? So what is GDP in 10 years? We would plug those values into our formula, and we would have 100 times 1 plus 0.05 to the 10th power. Okay? So important caveat here, you want to use that percentage, you want to put it in decimal form. You don't want to write 1 plus 5 equals 6, because that would be a huge number. That would be 600%. So you want to make sure you put this in the decimal form if you fill one of these out on an exam or something like that. All right. Okay, good. And then the other thing I wanted to go over was, again, this this graphical production function. Where was it? Yeah. This picture here. I tried drawing it on the slide, but I don't know how well it came out. So if we were to draw that over again, we would have a picture that looked like this. We could do this as capital down here, output up over here, right? And then we would have this production function here. And this is with technology number 1. So technology level number 1. And so you can see if we were to start off here at this level of capital, let's say it was K0, we would end up with Y0. And if technology doesn't change, then as we grow the capital stock, right, as we move along the x-axis, this is going to slowly start moving up the y-axis and output grows. But we know that technology doesn't stay constant. Technology does increase over time. So tech increases over time. And so we might have, so let's say this is tech, let's call it, I know we said it was tech number 1, but let's call it technology at time period 0. And then let's say this is the function for technology in time period 1. And let's say by the time that grows, let's say the capital stock went out to here. So let's say this is K1. Okay. So now with this new level of technology, output is actually up here now. Okay. And then let's say another period of time goes by and we're at tech number 2. So it might be the second year, second decade, whatever time period we're talking about. And by then, the capital stock might be out here. So let's call this K2. And this is what we get. Up that way, let's call this Y2. Right? So you can see here, we don't really move along a static production function because technology is like, it constantly slowly moves this production function up. And as we move along the production function as it goes up, it's like scissoring open and like raising the value up even higher. So the path that we're actually taking might look something like this. We might actually be going, you know, like from here to here, and then we go like so. Boom, like that, and we grow up to there like that. Okay, so that's the path that we might actually be taking. All right. Okay, so that is for the graphs there. I think there was maybe a couple problems we wanted to look at in the back, just to do a couple more examples. Let's do number 33. So that might be a good problem. So here, number 33 is an economy starts off with a GDP per capita of 12,000 euros. How large will the GDP per capita be if it grows at an annual rate of 3% for 10 years? What about 3% for 30 years? What about 6% for 30 years? Okay, so let's set that problem up. So I'll put that in the name of saving paper. I'll put that under here. All right, so this will be problem number 33. So if we start off with 12,000 euros, so that's GDP at start date. I use that kind of like an epsilon for euro. I don't know, that kind of looks like the euro symbol. So how large will GDP per capita be if it grows at an annual rate of 3% for 10 years? All right, so we want to know what's going to be GDP in 10 years. So it's kind of similar to the problem or the example that we just did. So at 3% growth in 10 years, GDP will be so it's going to be 12,000 euros. Don't forget your units. Times 1 plus 3%. Remember, turn it into a decimal. And 10 years. So it's going to be to the 10th power. Don't really need to calculate that out. I'm just more interested in you setting up the formula, what that looks like. That's what that's most importantly for me. You can plug this into Google and get an answer lickety-split, but I don't really care about that. What about 3% for 30 years? So for 30 years, it's going to be 12,000 euros times 1 plus 0.03 to the 30th power. And then 3% or 6% for 30 years. So for 60 years, it'll be 12,000 euros. Again, very important. Do not forget your units because we're not talking about 12,000 bottle caps here. All right, they're euros. Times 1.06 it is. Yeah, 1 plus 0.06 to the 30th power. All right, now since it would be homework if you get this assigned, you can go ahead and plug this into Google or any search engine and it'll calculate it out for you. But if this was on an exam, this is all you would be required to write. All right, and this is what I would instruct you to do. Okay, hope this video is helpful. Any questions on any of this or any of the problems in the back that I'm going to assign on the to-do list, please reach out via email. And we'll see you on the next one.